Makes it a little bit bigger. Thanks.
Okay, so I'm not sure what you're seeing, but let's just kick this off. So I'm Joseph Heller. Instead of referring to my presentation today exclusively as soil testing, let's talk about this more in terms of calling it a soil assessment. So I'm an urban conservationist. I've also had a lot of experience working on conventional farms here throughout New York State. I've seen a variety of different types of soils, everything from muck soils in the Orange County region, which are the basin of what used to be a wetland, and they were converted into highly organic, productive soils for growing, to constructed soils in what you might see in an urban city situation. So when we talk about urban cities, sometimes we often hear about soil contamination. And towards the end of my slide presentation, I'm going to bring that up. But for the purpose of today, what I'd like everybody to be focused on is observing the soil. So soil test is a very static word. And when we're working in the garden, oftentimes, as was mentioned early on by Don, it's a real fun, pleasurable thing to do. You're in the environment. So I want you to touch, feel, smell the soil. But if you have any inclination that you may have soil contamination, I'll go through some steps to help you do some testing and work with others to make sure that your soil is healthy. So we can go to the second slide. So again, I'm not actually seeing anything on the slide, so.
We're seeing a shovel full of soil.
Excellent. So do you smell your soil? I don't expect any of you to actually put up a response or answer, but you can give me a thumbs up. So anyway, I do. I smell soil often, probably like a lot of my other colleagues on here. And um, when I smell soil that looks like what you're seeing here in the picture, it's sweet smelling. It's typically considerations of a very good soil. When you hold it or look at it in your hands, it's a chocolate-like brown substance, and it has a very light feel to it. It's fluffy with lots of aerobic or pore spaces for oxygen to feed the living soil. It has a fair amount of particle sizes. So as you can see in here, and this is really compost actually, you can see there are very small pieces of sand silt or clay. But then again, on top, you see where they just put it into the compost pile and there was some residues that hadn't fully decomposed on top. Inside of there, and as you can see, it might be a little wet, but there's a lot of gooey substances, and that's all the humus and the really great materials that are converting themselves into available nutrients for your plant. As you heard Stephen refer earlier to that when he was referring to compost in the soil. Um, in the healthy soil, you'll also see rocks and living organisms, worms, you may see insects, but there's also many microscopic organisms that are in there at work. And we'll talk about them in a little bit more. So, like smelling good, healthy soil, has anyone ever turned over a compost pile where maybe recently fresh grass clippings were added? Well, it's harsh, right? You'll smell something that kind of takes you back a little bit. Well, that's anaerobic conditions where you're not having a lot of oxygen feeding the soil microbes, and chemicals are starting to form in the soil, like ammonia. So just two opposite sides of the spectrum when you're doing an observation, smelling the soil. So the essence of soil fertility, the mushy, gooey material in compost or just good soil, is the stabilizing glue that determines whether or not, say on a dry day, if there's no surface cover, like cover crops that were mentioned earlier, you may have wind erosion, or when there's heavy rains, they might wash through the soil and wash away your very valuable topsoil. So today we're going to focus on healthy soils and growing vegetables, assessing the soil. So again, we're not going to get too caught up in the word soil test. I want you to think about using your senses: touch, feel, smell. Um, and then as we talk about this, let's take a look at organic matter. So let's go to the next slide. Just let me know when it's up.
It's up.
Great. So you might have come across a word, soil tilth. So soil tilth is a physical condition of soil, especially in relationship to its suitability for planting or growing crops. Factors that determine tilth include the formation and stability of soil particles, moisture content, the degree of aeration, soil biota or living organisms, and the rate of water infiltration and thereof drainage. So soils should be full of life, um, with not just the biology that I talked about, but plant life. It should be high in organic matter. You want to try to leave living roots in the soil, even if you can, during the non-growing season, as was mentioned earlier with cover crops. And we'll get into this a little bit more. It's well structured. So here's a bit of a oxymoron. You want to manage more by disturbing less. So Stephen gave a really good example in his presentation about somebody over rototilling. So to capture on that, I'd like to tell a story too. Came across a farmer who had the best tomato crops, and he said to me, "Why were these the best tomato crops in all the years I've been farming? All I did was open up that patch of ground that I hadn't farmed on in many years." Well, that was just it. That living soil hadn't been disturbed in many, many years. So it was full of life. It wasn't compacted. It hadn't been disturbed. So when he planted those tomatoes were able to really access good nutrients, a non-compacted soil. And it was interesting to see over time as he maintained it, there was some decrease in productivity, but overall it was a really strong, healthy soil because it hadn't been managed or disturbed in many, many years. Next slide, please. So there are inherent and dynamic soil properties. Soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. Earth's body of soil is called the pedosphere, and it has four important functions.
Sorry, Jason, we haven't gotten to the next slide yet. Kim, can
Oh,
you
I'm
go to there?
sorry.
Oh, no, that's fine. It's not you, it's us. Thank you. Now you are. So now it makes sense for people.
Great, great. So again, so soil is a mixture of it has inherent or dynamic properties. It's the mixture of organic materials, minerals, gases, liquids, organisms that together support life. Earth's body of soil is called the pedosphere, has four important functions as a medium for plant growth, a means for water storage, supply, and purification, as a modifier for Earth's atmosphere. We're hearing a lot now about climate resiliency, storing carbon in the soil, and it's also a habitat for organisms, and very important for human life as well. So all these functions in their turn modify the soil. Changes in dynamic properties depend both on land management practices, for example, neglecting the soil, leaving the soil bare rather than covered where erosion can take place, or on the flip side, managing by using a cover crop over the winter, and the inherent properties of the soil, which are constant. So we may be able to change the dynamics, but inherently particle size, depth to bedrock, sometimes texture and cation exchange. The reason I say sometimes on texture and cation exchange, because we may have the ability to change that, right? So with our soil pH, we can change the chemical variations of the soil composition, as well as the texture by adding different amendments or minerals. So let's go to the next slide. Just gotta give me a heads up when it's on the screen.
Yep, it's up.
Great. So this is the soil texture triangle. Many of you may have seen this. Sometimes, like again, you talk about soil testing and a lot of complicated information when you're looking at soil. Sometimes I think we overcomplicate it, right? So a good soil has a mixture maybe of all these different elements along with organic matter. But in order to really better understand soil particle size, clays are actually very small. If you were to compare all these at their actual sizes, clays would be about the size of a dime. Silts are a bit larger, so they're about the size of a frisbee. And Sand would be about the size of a beach ball. So in the bottom left corner, you can see here some ideal um, components of what soil is. And if you look there, air is 25%. Now, sometimes you might say, well, what do you mean air? Air and soil? Well, it's extremely important. And as we go through this presentation, you'll see some more information about why. So let's go to the next slide.
Yep. Yep.
So here again, I want everybody, I wish we could all be together. A lot of times these are done in person when you're doing soils to feel the soil. So on the top right-hand corner, you're looking at a clay soil, and that's actually called a ribbon test. I'm always impressed by people who can make a really good ribbon. So basically you're kneading the soil in your hands. If you can create a ball, or if you can actually do this ribbon test, and there's a whole process to do it, you can really identify that you have that clay in your soil. The second photograph right there is a sample of what some silt would look like. Now, this is representative. You know, you might say, well, what is the difference between clay and silt? They kind of just look so similar. A lot of times after there's a washout, or if you see erosion from a gully or a rill, it's that sediment that's actually left behind often is silt. So it has a texture almost like a baby powder to some extent. But it's a very important part of the soil structure as well. And at the bottom, you can see the granules of this sandy soil here. You can do what's called a jar test. Again, it's not big on the word test, but it's a bit of an assessment. This is quite a simple way of you observing the sand, silt, and clay in your soils. So as you can see there, the clays are so fine that they're actually just showing up in the soil solution just up top. So let's go on to the next slide.
What's up?
So again, healthy soils are full of life. You can see here, pore space is so important, up to 50% of what we're looking for. And one of the reasons that pore space is so important is because that's where you're having this chemical reaction take place in the soil. So that's where the organic matter, which as it's breaking down various stages in decomposition, cause that soil biological activity that's exchanging the elements. And we're going to get to that in a few more slides. So that's where, when organic matter is breaking down and those nutrients are becoming available, it's coming from living organisms, fresh residues. It actually creates a stabilization in the soil. Again, it's all that gooey material that you find in really good compost. And then along with that, you know, the bacterias and the other micro and microscopic organisms that are breaking down that and releasing those elements into the soil solution. So we'll go on to the next slide, and I might have to kick it into high gear here to meet up with the timeline. So this is a representation of that soil solution that you're seeing, and what I've been trying to refer to about that biological activity that's happening in the soil. So as you can see here, and I apologize for anyone that has unable to see the color differentiations here, but you can see here where I like to look at that brown dot, and that's plant and fungal debris that are being starting to break down, and it gets surrounded by soil particles. And soil particles like clay and silt have a negative charge. So when those nutrients and are becoming available to the soil solution, they actually get attracted to the soil, almost like Velcro. They can stick on. So through a chemical process, and I'm just rushing here because I know I'm running out of time. Let's go to the next slide.
What's up?
You can see the soil particles, right? So those little gray circles that were in there, the gray and yellow in the previous slide, have that negative charge. So as those nutrients are being released, they're from the soil particles, they're able to be absorbed through the root hairs as a positive ion. So that's actually how this chemical reaction takes place. It's a transfer and exchange of negatively and positively charged materials in the soil. Um, so plants absorb CO2 from the atmosphere through photosynthesis. They pass carbon to the ground when dead roots and leaves decompose. The elements here, carbon is released into the soil and it's reacting with water, and as a result, bonding with the soil particles, and these elements being nutrients. So we'll go to the next slide.
Kim's got you all set now. She's almost there before you.
That's great. You can hear my pause. Again, just referring back to the healthy life of soil and why it's so important. And I think based on time, I'm just going to click through without sort of reading off slides. So let's go to the next slide. So these are some of the tools that as professionals we use when we're soil sampling. You can see here in that left-hand picture, that's a core sampler. If you're really starting to manage your soils and other people's soils, is something you may want to invest in, but you really don't have to. A typical garden spade, as you see, to take a representative sample. On the right-hand side, I did show how you might sample soil in a pattern around your garden or your farm. Sometimes when we're taking a look at different problems on the farm, we will actually use GPS to focus in specifically on where those soil samples are taken. But an average sample of across your garden should suffice in terms of collecting a sample and sending it off. And I will put in the chat where you can send your samples as well. So let's go to the next slide.
She's there.
So we talked a little bit about pH, and I wish I had a lot more time to talk about this, the measure of acidity or alkalinity in the soil. And that's actually what allows those nutrients to become available in the soil. If you're swayed too far one way or the other between acid and alkaline, those nutrients aren't going to be available to the plant. However, there are some plants that do prefer those acid situations. So really understanding your soils. If you were to do an observation, I was going to ask this as a question, but there are sometimes different indicators. Mossy conditions on a soil are an acid indicator as an observation. And then we'll just go to the next slide here.
So, yep.
However, nutrient test kits are available. I'm here just showing a sampling. So after that sample goes to the lab, or if you're doing it at home, you can purchase these quick nutrient and pH test kits. Very simple. Don't get intimidated. They're really easy to use. And as you mix up your soil sample in the test tube, you can match it up to the color charts to get the range of what your soils are. So let's go to the next slide.
It's up.
So in terms of heavy metals, urban and suburban areas may have large amount of contamination, often deposited well before the garden is considered. These contaminants may have leached into the soil in some cases, though, as airborne particles deposited on the soil from lead or smelting plants. Many urban areas have a history of land use, and in New York, there were peaks in these being in atmospheric conditions. Places like New York City, Buffalo, Albany, and Utica are places that could be considered hotspots, or they are located. So there are a lot of mitigating risks. NRCS does have an XRF device. It's an X-ray inflorescent device that you can use. And you can see here, these soil scientists are measuring and monitoring lead and other trace elements in the soil. Next slide.
It's up.
Another observation is soil color. Browns, yellows, yellow reddish, yellows and grays are all good descriptive colors of soil, but they're not always very exact. There are soil scientists that will use these types of, it's called the Munsell soil color chart. And as you can see here on the right, this slide here is showing actually the bottom of that muck soil, the wetland. So consider the fact that this was probably the bottom of a lake 10,000 years ago after the glaciers melted, and that the reason it became a lake is you can see on the bottom, there's that real gray soil there. There's no air pockets. It's very dense clay material that just holds the water. And that, as you can see, over time, as soil structures may have been developing, maybe more aeration and so forth, you get to the top and you see very rich organic soils that are full and teeming of life. Lots of pore spaces, bulky materials, almost wood chippy like very small pieces of organic matter that are providing substantial pore spaces and nutrients that are available to the plants. We'll go to the next slide.
So,
So this is actually an indication of some poor soils. They're soils that are seasonally wet. So you can see here where there's that red little area of this soil, and that's where there were irons that were in the soil. And because there wasn't a lot of aeration, because it was inundated with water, those elements were not able to really release themselves from the soil. So instead, they stayed in the soil, and as you can see here, probably didn't provide great health for those plants to grow. Let's go to the next slide.
so
So some of the ways that I want to talk about compaction. Compaction often happens in areas, obviously, where they're very trampled down. Sometimes our urban gardens see a lot of this based on the fact that it was human traffic, vehicular traffic. But oftentimes in agriculture, we see this due to over management. Again, things like tilling, breaking down the soil structure, removing the organic materials, and not having enough organic components in the soil that help give it good structure. So what you're seeing here is actually a very popular tool. It's called the penetrometer, which measures soil resistance. It might go up to 200 pounds. That's probably about the max. So you could also go down and measure the depth of the soil to where it gets very hard. And that's very important, knowing how deep your roots are going to be able to advance inside the soil. Let's go to the next slide.
it's up.
So what are some of the things that you can do to reduce compaction? And again, we talked about cover crops. Cover crops do a lot of great things, and they can actually manage the compaction. Here you can see there's a tillage radish, and those circles this is in the springtime after a winter kill, and you can see some of those tillage radish, the tops that are just laying to the side, but those really great holes that were moving the soil and breaking it up, so that you don't have to rototill, like we heard from Steve, that you can just take a tine and easily manage that soil, keeping all that soil alive, right? So if you turn that over, and that's all those biological activities going to get exposed to the sun, and simply they're just going to die off. Let's go to the next slide. So again, just looking at really good soil health and looking at pores in the soil. Earthworms, they channel, you can see that. On the bottom left-hand side, you can see that's estivation, and that's actually where there was a drought situation. And those worms actually created a small pocket in an airspace, and they actually go into a dormant period. So if you see that in your soil, it's a good indicator that those soils tend to be dry out and not have the structure that would be very conducive to growing. Next slide.
Joseph, I'm going to interrupt you just for 1 second. I think we're missing our next speaker, so I would say keep going.
Okay.
Unless Adam
Okay.
suddenly pops up and says he's here, but I'd say just keep going.
Okay, so I could slow down a little bit.
Yes.
And
So
I
the next slide.
apologize to the audience. So looking at this slide here, this is you're seeing the one with the vegetable crops and the drip?
Yep.
Excellent. So sometimes it's just unavoidable that when you're in the spring and you're planting your crops, that the soil is going to be exposed. So when looking at this, it makes me concerned, again, because you do have the potential for all that good biological activity in the soil to be exposed to the sunlight, exposed to erosion. So some simple things here that can be done would just be to put straw down in between those rows. That will help keep the soil in place. You might actually consider a cover crop in between those rows as well, although you wouldn't want those cover crops maybe to outcompete with the vegetables that are growing. But overall, this is a very successful farm. I would just say the only shallow part of their management was that the soils are just um, highly exposed when they don't have to be. I shouldn't say that. Maybe sometimes it's a limiting factor with funding and financing, but something to consider when we look at that. It just makes you think like you're going out in the sun without suntan lotion.
And now no, Adam's here, but so just keep going. And, if, I
Okay.
don't know how much more time you have, but we'll fit him in.
Okay, I'm just about to the end. So here is a slide just talking about cover crops and the importance of cover crops. This is some science that's being done by Cornell and some of our research scientists around the state. And what they're looking at is growing cover crops, scavenging nitrogen. They're looking at triticale and field peas. So you can see the difference between the left and right where cover crops were used and how it really impacted the health of the soil and the lush green growth on the right versus what you're seeing on the left. Next slide.
What's up?
So healthy soils are covered all the time. You can see here in this snowy condition up top where it was a cornfield, it was left maybe with just the residues from the corn after it was harvested. However, on the bottom, you could see where there was a real healthy situation where cover crops were either planted just after this crop, most likely just after this crop of corn was taken out. But on the top right, in the middle, you can see what's called interseeding. And that's where they actually plant cover crops. This is multi-species cover crop in between the corn rows. So corn can be highly erodible because those rows are typically exposed. But here's a great example of how those two crops can work together and you can maintain that healthy soil all the time. And then I love this picture all the way on the right. It's just an urban farm where they left all of the residues. And you want to resist the urge to clean up gardens until after temperatures are constantly above 50 degrees. There are many wildlife, butterflies, bees, and other pollinators that are overwintering in the dead leaves. And it's the circle of life, right? So it's the soil, it's the what's living below the ground and above ground that really helps your gardens thrive and grow. Next slide. So this is a What Gardeners Can Do, 10 Best Practices for Healthy Gardening. That's created by Cornell. So my slides will be available and all this information is available to you as well. So you'll find some really good information here. There's also good information about if you have heavy metals and those contaminations in the soil and where to find the information to remediate those heavy metals. You also want to be concerned, it may not just be heavy metals, but there also could be other contaminants. And you may just want to work with EPA or some other soil testing labs to ensure that if you have that fear of contamination. So next slide, please. So NRCS has this great site called the Web Soil Survey, and you can actually go and identify what your soils are. And there's also a lot of great information in this site about how to manage your soils. This is used by everybody from engineers to gardeners in their backyard. So I would encourage everybody to utilize this site. You can map out your location. It could get a little grainy on different as you get closer and looking at the resolutions on a map. However, really good information and can give you a good history of what your soil is, as well as how to proceed moving forward. Next slide.
Yeah, it's up.
Great, great. So these are some of the components of things that I went over today. Due to the essence of time, I probably won't repeat this. It was a little bit of a filler in case I ran short on time. So I just want to thank everybody. And as the next speaker comes up, Adam, I will be putting a few things in the chat box that are related to my presentation. And then just the next slide is our non-discrimination statement. USDA is very actively engaged in ensuring the inclusion, equity, and diversity of the work we do and the people that work with us. So thank you very much for having me here.
Thank you.